Okay, I'm breaking this last section in this into two videos because it's a fairly big topic, although it's fairly straightforward, but I want to give it a nice thorough treatment. So what we're going to talk about is we're going to talk a little bit about what we call a square root. A square root is basically going backwards from squaring a number. So if we take a look at our perfect squares, which is to say numbers that result from squaring a number, from squaring another number. And we're going to find, well, hopefully a familiar pattern, I hope. So if we've got 1 squared, that's just equal to 1. 2 squared, it's 4. 3 squared is 9. 4 squared, 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. And notice that all we're doing when we're squaring a number, it's just the number times itself is equal to what we call the square, or the perfect square. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. And if we wanted to, we could continue this pattern on. 13 squared is 169, and so on. Well, with a lot of math, we show you how to do things in one direction, then we turn around and show you how to do it backwards. And what we call a square root, we use this symbol right here, which is called a radical. And if we put a number under that radical, say 16, this number under here is called the radicand. Now, when we evaluate this, we'd say that the square root of 16 is equal to 4. And that's because, oh, by the way, the answer to something like this is called a root. And this is because 4 squared is equal to 16. Now there's a couple things to note with this, that if we've got a radical like this, is there any way I could have a negative number under that radical? And if you think about it, so say I've got something like square root of negative 25. Can I do this? And if we think about this, if I say, oh, 5 squared was going to be 25, and if I take negative 5 times itself, negative 5 times negative 5 is going to be a positive 25. There's not a number that would actually give me a negative 25. So what we'd say is, this is not a real number. Which begs the question, is there such a thing as a not real number? Yes, there is. But we're not going to talk about it right now. Now, let's go ahead and talk about some of the things that you're going to run into when you're doing this. There's a couple things that we're going to deal with, and we can talk about things like approximating. So we've got something like the square root of 7. If I take a look at this, I notice that 7 is in between a couple of my perfect squares. 4 is a perfect square. and 9 is a perfect square. And 7 is in between these two, which means that if I'm looking at this, I would expect that this number would be in between, well, the square root of 4 and the square root of 9, because the square root of 4 is a 2, and the square root of 9 is a 3. So this is going to be somewhere in between this 2 and the 3. And looking at this, we could, if you were to plug this into your calculator, you'd find a number that's like 2.65, or actually 2.645 and a lot of change. The funny thing here is this number is going to be an infinitely long decimal that is not going to actually repeat. But for our purposes, you'd say, oh, this is going to be somewhere in between 2 and 3. The other thing that we're going to do, now this is something that we will use a calculator for. And just to note, in your homework, I've given you questions that you should not need a calculator for. I still don't want you using calculators. But let's take a look at what might happen if I've got something like this. Say the square root of 25 over 64. One of the things that we can do if we have a fraction under a radical is we can actually separate this into two separate radical expressions. So this would actually be, the square root of 25/64 would be the same thing as the square root of 25 over the square root of 64. This would be the same thing as 5/8. Okay, that's pretty much all I really wanted to show you with our square roots. If you have any questions, shoot me a message. Otherwise, I'll see you in the next video.